Alright, so the fourth problem from today's weekly contest sorted GCD pair queries. Uh, this is a good one. We are given nums and queries. We need to find the answer to these queries, but how? Uh, we basically need to find something called GCD pairs, which is essentially uh, for every possible pair that there is in nums, we find the GCD of that two values within the pair and we add it to an array. We sort that array. So the sorted version for this example will be from 1 to 1 it will become 1 1 2, and then we basically find the answer to each query, which is essentially uh, what is at the second index. 2 is at the second index, so uh, 1 2 2 will be the answer, right? That's what the question is. Right away, if we take an example, all right, uh, suppose this is an example 2 4 8 uh, 16 64. All right, this is nums and we are asked to get something called GCD pairs, right, which is nothing but something of this sort, right, something like this. But this is what we don't really need exactly this, right? We can also get something of a compact version, something like uh, each index representing this and ans value will be a count to it, right? So essentially 1 2, right, and 0 is 0. This is basically can also work out, right? Let's forget this, might be getting confusing. So what I really need is GCD pair of I. What is this? I don't know. Well, what if this I was 8? GCD value of 8 is nothing but it is nothing but what is the count of pairs which has a GCD of 8, right? So this is nothing but I, alright? Count of pairs which has a GCD of 8. So let's calculate it for this example. 8 and 16 can be a valid GCD pair. I mean potential valid GCD pair. 16 864 can be a potential candidate. This can be a 1664 can be a possible candidate. Suppose there was another 16 here. It can have repeated values. So 816 can also be one more candidate. So I see 4 candidates, or actually even more. Now that 1664 is also a candidate. 1616 is also a candidate. Why are these candidates? Because there's one thing in common here. Every number here is a multiple of 8, right? That's why it's a candidate. And I found that there are 4 numbers which are multiple of 8. How does that help me? Let's find out. Uh, what is the GCD of this? 8. GCD of this 8. GCD of this 8. GCD of this 16. GCD of this 16. GCD of this 16. So I essentially see that uh, there is 6 pairs, out of which only 3 are, number of pairs which has a GCD of 8. But there were 16. What if there were another few, like 64 suppose? So there will be another uh, couple of candidates, 8, 64 again, 16, 64 again, 16, 64 again, right? This will be 16 again, this will be 16 again. Right, suppose there were other candidates as well. I keep on adding it uh, to this, but essentially I basically need the ones which is having a GCD of 8. What I'm trying to say is this can be calculated like this as well. Every possible pair of 8 or multiple of 8 is 6 minus every possible pair of 16 or multiple of 16. I'll keep on subtracting until this particular number goes out of my out of my range. Basically the ranges from 1 till the maximum number in nums. Okay, that's the ranges. So I'll, for this example, we'll go till 64. Alright, I think I added extra 16, 32, 48, actually no, 24, 32, 40, 48, 56, 64. Essentially, these many I have to subtract from this pair to get the GCD pair. This is another way to calculate it. So okay, then how do I calculate this? This is very easy. This is nothing but how many numbers are there which is divisible by 8. Well, 1, 2, 3, 4, 5. 5 numbers are there. Right now this is not equal to this. We are yet to do that, but we are getting close to it. So 16, how many numbers are divisible by 16? 1, 2, 3, 4, 4. This will be uh, again 4. This will be 2. This will be 2. This will be all of them. So 1, 2, 3, 4, 5, 6, 7. This will be 8. Alright. So essentially this is what I get. Now if I have 5 values, 1, 2, 3, 4, 5, and every pair I form will be a 8 or multiple of 8, right? So I can use the formula NC2, right? Because I am making a pair. So right here it will be 5C2 by the way, which is nothing but NC2 is generalized, which is nothing but uh, N into N minus 1 by 2. Alright, so I can calculate this. So essentially I'm calculating this, and if I do this for every particular multiple and subtract it from this, I will get the GCD pairs. Now the last thing is there can be repetitions, so I can essentially do it in a much better way by calculating the compact form of something like this. So this is 1 in number, 1 in number, 1 in number, 2 in number, 2 in number. right? And I can use this count to essentially calculate the possible divisors, which I calculated here, and then use that to calculate the pairs, and then use that to calculate the GCD pairs, and then finally I can use GCD pairs, which will be nothing but this particular thing, but in compact form. So it's nothing but 2, let me write it like this: 0, 1, 2, 3, 4, 0, 1 is 3, 2 is 2, 3 is 0, 4 is 1. I'm sorry. So this is what we will get in GCD pairs. Now how do I calculate my answer? Using queries. So I will use each query. I will also calculate the prefix, right? So essentially 5 is this number, right? But how do I get it from here? I will do a prefix here so that I can do a binary search of this query on this prefix, and that will give me my index, which will be my answer. So if I do a upper bound on this prefix, since this is sorted, this will give me 0, 1, 2, 3, 4, and 4 is my answer. So I'll do the same thing again and again. I'll get my answer. Alright, so let's do that. First, we get the frequency, right? That's the foremost thing. N is equal to nums dot size and int frequency vector of int frequency, which will be of size n, sorry, which will be of size equivalent to the maximum element in nums, right? So the number of elements or the values in numbers can go from 1 till this, or essentially the maximum element that is there in nums of 5. So I can calculate that so that we can use it later. Alright, this will give me the maximum element. I can use that to form the size. So I will traverse and I will update the count. Now that I have formed the frequency, I will form construct, what should I call this? Well, count as divisors, because for every number I'm counting the number of times it can act as a divisor in nums. So essentially count as divisors. So vector of range, let me call that count as divisors, and that will be of also size max element plus 1. I will basically iterate through the entire range that I can have. So alright, and for each number I'm going to get the number of count. So if I have till 64, right, from 1 till 64, so for 8 there will be 8, there'll be 16, there'll be 24, there'll be 32, there'll be 40, there'll be 48, 56, 64. So I'll get that count as the entire value for 8, and then I'll do the same thing from 8 till 64, whatever 16 multiples I can get through. So essentially I'm traversing the multiples. So from I am traversing the multiples till max element, and that will be an increment of j plus equal to I. So this will give me the table for this particular value, and that I will add it in my count as divisors. Uh, but since there will be multiple 16s, multiple 64s, then I will use that count from my frequency, and I'll add it that many number of times. This will construct my divisors array. Now I'll construct GCD pairs. Well, let me get the vector of long because values can be long. GCD pairs. Again, size will be max element plus 1 for every number within the range. So this is the range. I get its pairs, right? So I have the divisors. Using that, I will get the possible pairs for this number. So essentially, when I calculate this for a particular number, I'll need the future values, right? So it's better to go from back to 1 instead of going from 1 to max element, right? So that by the time I reach 8, I will have it calculated for 16, 32, or 40, 48, and so on and so forth. By the way, this should be 24. I hope you pointed that out. 48, 56, 64. Alright. So I will go from max element greater than equal to 1 minus minus. Here I will essentially from the next multiple of I will start subtracting, right? So that's what I'm going to do that inside this loop, but before that I will initialize GCD pairs of this particular value as the number of pairs using this formula, right? Essentially, this n is nothing but the number of count or the divisors, number of divisors that I already calculated here of I into of I minus 1 divided by 2. Let me put the brackets, and this can be for big multiplication, so let me do a long, and then from this next multiple of I will traverse till I can, and since these will be multiples, so I will add j plus I equal to I, and I will keep subtracting from I the next few, because these will be the future values by the time I reach to I will have calculated it. GCD pairs of j, I'll keep subtracting. Now I will have the GCD pairs. I will construct the prefix. For that I will have a vector of long. GCD prefix is what I call this. This will be of size max element plus 1. I will add one value to it as yeah, I will add 0 to it since we have this uh, base value so that I can build on it. I will start from 1 because for 0 it will be 0, right? So I start from 1. GCD of 0 is 0. So max. So count will also be 0, right? So I'll start from 1 and I'll go till max. I'll go till, sorry, yeah, max element plus 1. Let me do it like this. or let me do it this way, max element. Okay, so this is what I will do, and finally I will add that in my prefix, but before that I will initialize it with the last element of the prefix, and to that I will add GCD pairs of I, and this will be sorry, this will be it. Finally I will create my answer, which for which I will traverse through queries. I will get my answer, which is basically an index, uh, and in that I will basically doing a binary search of upper bound on GCD prefix. I'm sorry. GCD prefix dot begin dot end. What I'm searching, queries of I, and finally dot begin. This will give me index, and that will be my answer. Right? Let's see if this works. Alright, there is some mistake. GCD of pairs. Stored size. I'm sorry, spelling mistakes. Queries. I hope this is it. Let's see if this works out. Alright, now it's GCD prefix dot begin. This is okay. Oh my god. I didn't even declare answer here. So let's not forget that. And there are a couple of more errors. GCD pairs of G. Oh my bad, this should be J, not I. Oh my bad, I shouldn't initialize this since I'm building it. Let's see if this works. This does. Yeah, that's the fourth problem. Thanks.